Hey all, welcome to the channel. So today we'll be discussing about Kubernetes, the architecture of it. So I won't be going back and discussing about the difference and benefits of Kubernetes over Docker and virtual machines and all, because that is available over the YouTube. You can go ahead and watch like the several videos. So I'm mainly making this playlist actually for like explaining you about the components the Kubernetes have. So I was not able to find very helpful architectural videos on Kubernetes. It was difficult for me to get the flows and what each component does over YouTube. So I thought of creating my own videos, like exploring the components here and there, like, and so that it will be easier for you guys to understand it. Okay, so let us begin. Kubernetes cluster is created using several nodes. So these nodes are nothing but virtual machines. So virtual machines, we can assume it as laptops as well, which has its own RAM, CPU, operating system, and other things. Alright. So these nodes are segregated as master nodes and worker nodes, wherein we have the master node, which holds the Kubernetes control plane that controls and manages the whole Kubernetes system. And the worker nodes that the actual application we deploy in. Control plane components. Let us talk about them. We have the API server, the etcd, the scheduler, and the controller manager. The API server with which we and the other control plane components communicate with for the whole cluster. Okay. Now we have the scheduler which schedules our app. Basically, it assigns a worker node to each deployable component of our application, depending on some criteria. Okay, we will go deeper in later videos. And now the controller manager. Controller manager is the one which performs cluster level functions such as replicating components, keeping track of the worker nodes, handling node failures, and so on. We have different controller managers also. We'll dig deeper later on. etcd is the single source of truth for the Kubernetes cluster. That is a data store, and it's a key value data store basically, and it persistently stores the cluster configuration. So these are the control plane components. And with respect to the worker components, so we have the kubelet, the kube-proxy, and the container runtime. So these container runtime are like Docker or Rocket, which basically runs our container. Kubelet is the one which talks to the API server and manages containers on its node. Okay, and the Kubernetes kube-proxy, that is the Kubernetes service proxy, is the one which is responsible for load balancing the network traffic between the application components. So now the request flows. The API server is the only guy that can directly put the things and update this cluster state to etcd. Nobody else. Scheduler and controller manager keeps on checking about their own tasks. If they keep on watching the tasks, and like if there's any task for them, they do it accordingly. Also kubelet and kube-proxy also talks to the API server. Talks as in basically keeps on checking whether they have any task for them. And container runtime, kubelet gives the task to the container runtime to perform specific things like running the containers. All right. And sometimes the API server also talks to kubelet. So when we do fetch the logs of the cluster or the pods, okay, so that is the only time when API server talks to kubelet. So basically the API server only make requests to etcd and the kubelet sometimes, not every time. And apart from that, every other guy except the container runtime makes their request to the API server. Nobody else talks directly to each other without API server. To understand it in an easy way, what we can think about is we can assume the API server as the TL, the lead, the scheduler and the controller manager as the workers, and the TCD as the boss. So what we generally do is we keep on asking about the task from our TLs, right? So we make requests to our TL, and ultimately the TL updates to the boss. So that's how just the API server updates to the etcd. Yeah, to basically memorize it, it is easier to think about it this way. So this is the basic flow for the request in a Kubernetes cluster. Hope I guess you guys understood it well. That's it for the video. Thank you.